we want to find this missing angle here. Looking at this triangle inside the circle, it's been made with radius, radius and a chord. We have two sides that are the same length. That means we have two angles that are the same. It's an isosceles triangle, so that angle is equal to that angle. Angles in a triangle add up to 180 degrees. So this angle here, plus this one add up to 180. So we're going to do 180, take away 130 is equal to 50 degrees. That 50 degrees is going to be split equally between that angle and that angle as they are the same. So 50 degrees divided by 2 equals 25 degrees. So A is equal to 25 degrees. Okay, to find the missing angle B here, we need to use the fact that this here is the diameter of the circle. Because this triangle has been made using a diameter and two chords, it's a right-angled triangle. So we've got 38 degrees. We know this is a right-angled triangle. Our right angle is there. That's 90 degrees. Angles in a triangle add up to 180. So we're going to add 38 plus 90, and we're taking the answer away from 180 degrees. So 38 plus 90, 128 degrees. 180, take away 128, 52 degrees. So B, the angle we want to find, is 52 degrees. So for this question, we want to find the length of chord AC. That means this line here. We again have got diameter of a circle being used to make a triangle. So that means that this triangle is right angled and the right angle is there. So we have two sides of a right angled triangle. That means that we can find the third side by using Pythagoras. We know the longest side and we know one short side. So we need to do a take away or a subtract with Pythagoras. So AC squared, this side here, is equal to 15 squared, which is our longest side, take away 10 squared, which is the short side we've been told about. So AC squared is equal to 125, but I don't want AC squared, I need AC, so we're going to have to use square root to find AC. So AC is equal to the square root of 125. So AC is equal to 11.1803 ... carrying on. And to round that to two decimal places, AC is equal to 11.18. So we're told AO, this line here, and OB, this one here, are radii of the circle. Find the value of C. Because that side is the same as that side, because they're both a radius, means we've got an isosceles triangle. So therefore, that angle is the same as that one. So as we've done before by isosceles triangles, we take this angle here, the 74, take it away from 180, and then half it to get these two angles here. So 180 take away 74 is 106. So that 106 is split equally between these two angles. So 106 divided by 2, 53 degrees. So C is equal to 53 degrees. So in this question we're told that AB, this line here, is the diameter, and C the point and the circumference of the circle. These lines mean that that side and that side are the same length. So for this triangle, we have a diameter that's making the triangle. So this bit here is a right angle, but we're also told that that side and that side are the same length. So this also makes this an isosceles triangle. So that angle is equal to that angle. So we start by doing 180, take away 90, as this is a right angle, which is equal to 90. That 90 then has to be split equally between these two angles. So we've got 90 divided by 2, 45 degrees. So angle BAC, BAC is equal to 45 degrees. So for this question, we're asked to find the length of diameter DE. So from there to there. So in this question, we've got an angle and we have a side. Because this is a diameter, we know that this is a right angle here. So we've got a right angle triangle. So we're going to use trig to find this missing side. So the first thing we need to do is name our sides. Find a right angle straight across. That's our hypotenuse. Angle we're using, straight across, that's our opposite side. And the one that's left is the adjacent. So we tick off the information that we want to know and the information that we do know. So for this one, we want to know the hypotenuse. So we are going to tick off the h's. And we know what the opposite is. So we tick where we have O's. One with two ticks is the one that we use. We're going to use sine. So the sine 52 degrees is equal to the opposite over the hypotenuse. So we've got 10 over the hypotenuse. Because what we want to find is on the bottom, this is how we rearrange it. The hypotenuse is equal to 10 divided by sine 52 degrees. So the hypotenuse is equal to 12.6901, continuing on, rounding that to 2 decimal places. So hypotenuse is 12.69 to 2 decimal places. So DE, the hypotenuse, is equal to 12.69. So over this time, we are going to find the length of radius OG, this line here. This line coming along here is a tangent. Because that tangent connects with a radius, it creates a right angle here. So we've got a right angle triangle, we have an angle, and we have a side. So again, we're going to use trig to work out our missing side here. So the first thing we need to do, name the sides. Find your right angle, go straight across, that's the hypotenuse. Angle that we're using, straight across, opposite. And the one that's left is the adjacent. So we're going to tick off the sides that we know and that we want to know. So we want to know the opposite, so we're going to put ticks on the O's. And we know the adjacent, so we're going to tick the A's. So this time, the one with two ticks is TOA, so we're going to use tan. So tan of 30 degrees is equal to the opposite divided by the adjacent, and the adjacent is 30. So now we need to rearrange this. We want to get this by itself, so we're going to multiply both sides by what's on the bottom. So that 30 is going to come up here. So 30 times the tan of 30 is going to be equal to the opposite side, which is the one that we want to find out. So 30 tan 30 is equal to 17.3205 ... going on. Rounding that to 2 decimal places. So OG, this one here, is equal to 17.32.